Yes, my name is Bjørn Lindi. I'm from NTNU. I work as a research software engineer here at the HPC group. And I've been part of the HPC group for almost 2 decades, so starting in 2004.
And hi everybody, my name is Radovan and hi from snowy Tromsø, where also I do research software engineering support in high performance computing programming, and really looking forward to this session where I will be watching the collaborative document that we are now sharing on the screen. So please participate by asking questions, giving comments, giving suggestions. We do this so that you don't have to ask in voice, because that then makes it easier for us to edit the video. We have seen that using the document, we get many more questions than we would get by microphone. So please ask. We plan to have an exercise session around 9:40, but until then, we will be discussing and asking questions, and we try to keep it really, communicative. So please participate.
Yes, so let's start with today's themes: accessing software. So how can we find out what software is installed on Saga and Fram and Betsy? These systems have an equal install system for software. So once you can handle one system and find your ways out, or find the software you need, you can find the software on all of them then. So the objective is really to understand how the Unix system looks for installed software, and understand how to load and use software packages. There are something called the module system that provides commands for us for loading modules, and a module is a software package. So we can then search for software with a command called module avail, and load the software with module load, and clean the whole environment that we have with unload with module purge. But you will be doing this later on, so we'll get some feeling on how this is done.
And I can add here that what we will demonstrate this on Saga, and we will practice on Saga, but what we show here is really general. You can find this approach to making software available is really general, and you can find it on almost any computing cluster. So what we will learn here today will be applicable also to other clusters later. And we will explain why this makes sense, why it is done this way, and why this may be different than on your own computer.
So when you get an account on Saga or Fram or Betsy, you really just get a very bare environment where you have nothing else than storage and in a home area. So if you don't install software yourself, you are depending on installed software, and you need to search and find the software that you need. So, but before we go into this individual software packages, we should understand the reasoning behind this approach. And this is due to the 3 major reasons for using a module system is that we have software incompatibilities and versioning and software dependencies. So if we didn't have a system where this that kept track of the different versions and dependencies, we very fast would develop into a non-usable system.
And I can add here that one more reason is why we need something different than you have on your computer is that on your own computer, you decide what version you want. But on the cluster, we have, how many users do we have? I don't know, 1,000, 500?
Something like that, yes.
So, and everybody wants something different. Like one person wants Python 3.11 and another person wants Python 3.8 and another person needs the NumPy version 1.24, which means that it would be impossible to agree on the version that everybody needs. And that's why we need a system so that to make it flexible, so that every user can choose what versions they want, so that they can load their preferred versions and everybody can have their own environments. That's why it's different. And that's why we do this session here.
And so you can end up in a situation where the software package that you need is not installed, then it's possible for you to install it yourself in your home area. So it's fully possible to install the specific versions for software that's not on the cluster. And if you're not able to do it yourself, you can ask for support help.
Yeah, so this is surprising to many people because that you can actually install software yourself. I'm not saying that it's always easy, but it's possible. This is not something we will teach today, but please still ask about it. So if you have questions about software installation, please ask questions. We have another training event that focuses more on the installing software part, but we want you to know that it is possible. You can do it, but you can also ask us if something is missing and there is a good reason why we should make this software available. Then we are happy to do that.
So the reasons for this module systems are to deal with software incompatibilities and versioning and dependencies. So and when it comes to incompatibility, if you work with software, you might have experienced the difference between Python and Python 3 or different versions with C compilers. So Python 3 famously provides a Python command that conflicts with the provided Python 2. Here it says provided by Python 2. That's no longer the issue when it comes to Saga, where Python 2 is not installed per default anymore. So for Saga, we have taken the decision to focus only on Python 3. So this may be an issue for some, and there we have the incompatibility reason for this. Software versioning is another common issue. A team might depend on a certain package in the software version. If the software version was to change, and that has happened now on Saga, as Saga went through a major upgrade this spring, and it will happen on Fram in one of the coming weeks. And this may affect your results, or it may affect you in a way that you don't foresee. Let's say that you inherit scripts that use old software versions, then you need to modify these scripts for you using the newer versions of the software. We will also see that even though we need just one software package, a software package has a lot of dependencies. So, and these are specific. So, for example, WASP material science software may depend on having a particular version of the fastest Fourier transform in the West. And this goes for other software as well.
Yeah, so dependencies are something we all have to deal with. Almost any package depends on other packages and libraries, which in turn depend on other packages and libraries. So there is a whole dependency tree, and we might be unaware of it, and but we will see that later. Later, when we practice this and try to so-called module load a specific software, we will see that it will load also dependencies. So we will really experience that. But please ask us questions. So far, we have 0 questions. So please ask what you always wanted to know about software availability, installation. Ask away.
So here we have an example with the Python. We could try that out on Saga. So
and right now people should only watch, right? We don't.
Yeah, only watch.
Good.
So Python version here shows 2.7.18. And surprisingly, if we type which Python this is something that I have installed on locally on my home area. I don't remember why I haven't done it any longer, but I needed Python 2 for something. And if I try Python 3, Python 3, we get the system installed Python 3.9.14, which is installed on somewhere else. User bin Python 3. And there is, we see if the user, the system Python, that's the system installed Python command is the same as the 3.9.14.
Yeah, so I also tried it out here in. Okay, I was supposed to watch, but anyway, I typed. I tried it out on Saga. I got a little bit different results, but that's interesting, which means that we can have, because you have this locally installed Python version, so you see a different version than I do, and so we have this ability of really seeing different versions, and we will make, in a moment, we will make these versions really available through the module command. Somebody also asked on the document, on the collaborative notes, like what if we need more than one software? For instance, we need Python and R. Good question. We will show you how. So we will be able to load different so-called modules. So it will not be a problem to have Python available and R available in my environment. We will need to make sure that these modules are compatible, but we will discuss what that means and how you can check it. And this will also be in the exercise. You will learn how to verify compatibility of modules.
So what governs what Python I call when I call it from the command line is the environment variable path. So if my personal path variable is very long and has several modifications to it. So if I now just modify my path to what's comes with a fresh install, then you will see that the Python version is the same as the system as the Python 3 version.
Yep. So here we need to maybe take a step back and explain a bit more what this path variable means. It's very important. It's a very important thing to know about. So what is that? What is the path and what does it mean, and how should we?
So here, now, so this is the content of my path variable, and we see here that there are several directories. First, I have cluster home viewlin local bin as a subdirectory, and cluster home viewlin is my home area. and if this exists, the shell will search in for Python in this subdirectory, and if it doesn't find Python there, it goes to the next one until it comes to, and it doesn't find any Python before it comes to user bin here.
Yeah, so what the system does, it reads the path variable from left to right until it finds the software that I want. And we will in a moment learn how can we modify this path variable. So the path variable really determines of what kind of software do I see on the system. And we will not modify it manually, but what we will do is we will learn to modify it through the module command.
So, and if there are several versions of this, or several commands of the same name, Python, in several of these subdirectories, it will pick the first one. So, so when I had a Python in my local local home area, the subdirectory was at the left side, and it was the first Python command that was found, and that one was used. So the path variable can be something to inspect if you have troubles with versions and don't are able to call the command you like. We'll skip the exercise. We'll go over to the environment modules. And so software is installed as modules, and we call it the module system. And the module is a command also in the on the HPC system. Module help.
And it's available at least on all the HPC systems that I know. So it's not something that we invented. It's something we use, but something that you are likely to find on almost any high-performance computing cluster. And it's a set of commands which we will now use to where you can make available certain versions of software and combine them. And now we will learn how to use this command. Should we start like typing, or should we watch? How should we participate?
I think you should watch, and then
okay.
We'll leave the typing to the exercise. Module also, you can have a hierarchy of modules, so you can also have local installed modules in your home area if you prefer that. So let's see what kind of modules I have installed. So I have write module list, and I have currently only the standard N sticky module. Do you know what the standard N stands for, Radwan?
Oh, so you know probably better, but my understanding is that it's a set of software that we assume that everybody needs. So it's this standard environment, basically the bare bones functionality. But please tell me if you know better.
No, but I never seen a list of that software. What it is really.
Yeah, so I admit that I don't know what is inside the standard environment, but this is something we all get. I think there is the basic functionality to make sure that the basic things is working.
Yeah.
But we try to keep it as minimal as possible. and we want to give users the flexibility to load precisely the software that they need.
So a bare bone environment doesn't do much. So let's see how we can load a software. We can search for available software with the using the keyword, and the keyword search in the meta information. So let's see. I could. So with the keyword bio, I search for all the software that's installed which have descriptions using the word bio.
Yeah. Let's make that terminal bigger. So then there is we see some software, we see some descriptions. You can also try module keyword chemistry, and then there will be other software. So this can be a useful command if you want to get an overview of what is on the machine. It might not be a complete list because this relies on, here we rely that the software has been properly described and annotated with keywords. But it can give a good first overview. And thanks everybody for keeping the questions coming in. That's very nice. I'm looking and I will raise here everything that we should discuss here together. Yeah, module avail, let's look at that. That's a good command to know.
So a command that shows lists all the software, module software available. It's module avail. So then we see all software that is installed on.
Yeah, so this list can be a little bit overwhelming, but you see that there is a lot of software. And now,
there can be several versions. If you see NetCDF here is installed with several versions and several APIs for Fortran and C++.
Yeah. So if I now want to know what are all the different Python versions available, so then you can restrict module
and I can
avail.
restrict module avail to Python.
Yeah. And what I personally like to do is module avail Python / because then it will only show me the Python versions, not something that also depends on Python.
Yeah, let's see the difference. So if we have Python, then it's everything that's described with Python, and if you use then Python / then we have only the Python versions, right?
Exactly.
There wasn't much difference really.
Yeah, and here now now I can see that there are at least I can see 5 versions of Python, and if now I want to have, let's say, Python 3.10.8, now we can learn how do I load this? How do I make this available to me?
Then I write module load Python 3.10.8. And there is tab expansions, so you can just, when you have written the most of it, you can press tab to expand the command. And then if I now do a module list, we can see how my environment has changed.
Yes, so module load, what it really did, under the hood, it modified the path variable and some other things. But now we got some module list. I can see the dependency. So in our module list, number 14 is Python, but we got a whole bunch of other software. And these are dependencies of Python. So by loading Python, we actually loaded also all the dependencies that it needed. And you can also now try to do Python -- version, and then we will hopefully see that it's now 3.10.8, and it's not anymore your 2.7. Yep, so now we have 3.10.8 because that's the one we loaded. And if we don't like it anymore, we can unload it. And now I need to ask an important question. And where should we load modules? And it's a little bit rhetorical question. So the good place to load modules and unload modules is in your run script. Yesterday, we have created a job script. We have learned how to submit a job script. And a really good place to do this module load is in the job script. And the reason is then you do it close to your calculation. And later, if in 6 months you come back to your calculation, you also know what kind of dependencies you have loaded. So I recommend to not load them outside, load them in your run script.
But your run environment, when you run a batch job, will inherit your environment, right? So if you have modules loaded as you submit the job, these will be loaded.
Yeah, but the problem with that is that it might work now, but then if you try to run the same calculation in a few months, then your base environment might be different, and then the calculation might give a different result. It also makes it harder for us to help you if you send us a request, support request that something doesn't work. Here, can you please look at my example? And I try to then run your example, and I get a different result than you do because we have a different environment. So to be able to communicate the environment both to the help desk and to your future self, it's a really good idea to load them in your run script. Here in this session, we load them in the terminal because we want to, well, learn how does it work. But later, once you know, do it in your run script.
So we clean our environment module purge, and you should start your run script with module purge, so you're certain that you have a clean environment.
Yes. Can we try one more thing? And that is, if I want to know, so now we loaded this module Python 3.10.8. If I want to know what is in that module, what does it contain? If I want to have a little bit more information, and one thing I wanted to show is module show. That's something I use often, is if I want to have more details on a module. Let's see what we see. So there's a lot of stuff here. But what I wanted to show is that these commands here, they modify certain variables. One of them is path. So there is one line which contains prepend path. So it modifies the path variable, and we heard about what that is. It modifies other variables as well. And then on top, we can see that it also loads dependencies. So there is a lot happening. Sometimes I use module show to see what is really going on here. This is, so under the hood, if I do a module load, this is what's happening. Oh, good. We should go into an exercise soon, but there is few more things we wanted to maybe discuss. One is, what is a tool chain? Do we need to talk about tool chains? And then the other, but I already hinted on it, we need to show how to load this in the job script. And then I think we are ready for an exercise where you can practice these. Yes. So we have shown these things. So here's software versioning and toolchain. So we should discuss what is a toolchain, and then also talk a little bit about job scripts and modules, but we already have.
Yeah, so here we see GNU plot. It's made with a tool chain called GCC Core.
So what is a tool chain? How should people think about it?
The tool chain specifies which compiler suite that's used for building the software. So we have on this system, we have Intel compilers, and we have GCC compilers. So the GNU plot is built with GCC and GCC core, and the version number tells us which compiler version of GCC is used for building this software.
Yeah, and when people load one specific module, often you don't have to worry about the toolchain. It's something, let us worry about it. The moment when you need to start thinking a little bit about toolchains is when you start combining modules. And somebody earlier asked, oh, can I load multiple modules? Yes, you can. So you can load 2 modules, 3 modules. But when we talked about compatibility of modules, it's the compatibility in the toolchain. So if you want to make sure that modules are compatible to each other, then you need to look at the toolchain. So in our system, you can have multiple modules in your environment, but it assumes that they are all in the consistent toolchain, as far as I understand.
Yes. So if we want to load, let's say we have loaded GNU plot 5.4.2 GCC core 10.3.0, then we need, and we wanted to load a Python version, then it needed to be built with the same GCC core. Otherwise, we would have gotten a conflict. So here we see them using software in scripts. We recommend that you do module purge and then module load of the software that you want to use.
Yes, so the module purge, it's a good safety net to make sure it's to make sure that we don't accidentally inherit any modules from our environment that we work in, because that can make it confusing for you in future and confusing for us to help. It makes it more explicit of what do we depend on. So this is a very nice way here of doing it. It's about reproducibility.
Yes. So then we are ready for an exercise. So here you, among other things, I will find you load a module of R. And as I said, the Saga has been upgraded. So 4.10, which is referred to in the exercise, is no longer installed on Saga, so you will not find it.
So you can reload the page, or it will. Oh, we fixed this morning. So if you reload this page, it's all good.
Okay, you did.
Yep. Can we reload it?
Yeah.
And in the meantime, I can say that. So we will give you 15 minutes for the exercise, but let us first explain what we expect. Here you will be able to try out these commands, or see what software is available, module keyword, module avail. You will learn how to load a particular version. But there is also this bonus step where you can look at the compatibility and the toolchain.
I reloaded it, but
yeah, maybe it's cached or something. So it on my screen it looks a little bit different. Can you do like a hard reload with? Otherwise, I can maybe quickly share. Just a sec. I need to find it. Yeah, no, it's better.
There.
Good.
No, it's there. Okay.
Yeah, so your goal will be experiment a bit with module keyword, module avail. You will load a particular version of R, which is one of the softwares available, but of course you can also experiment with others. And then bonus step number 4 is look at the toolchain, look at the compatibility, and then try to load a compatible version of Ruby with the same toolchain. If you, Bjorn, if you scroll a little bit down, there is also, we have a solution. So if you get stuck, then click on the solution. We will not do it now. We don't want to spoil the fun. But there you find step-by-step solutions to these exercises. And we will give you 15 minutes. We will then come back. We will do a quick summary. And after the summary, we will then go into a break. Does it sound good? Did we forget anything?
No, I don't think so.
I think all the questions we have, some questions are not answered. We will answer them during the exercise. So keep them coming. Let us know how it's going, and I will place information about the exercise into the collaborative notes. So we have exercise until 55, 9:55. And I will also place the link to the exercise so that you can find it. Good luck. Keep the questions coming. Okay, it is 9:55. We have 5 minutes left. What should we do with the 5 minutes that we have? Should we demonstrate the exercise here, or should we raise some of these questions? Some questions are about installing software, which I think it's good that we answered in writing, but I think I don't want to go now into it here. We want to focus on using software here. Not so much on installing, but we have good documentation. We have other training events on that. What should we do now? Should we try it out? Bjorn, what is your opinion? We have then 4 minutes left, and then we will take a break.
Sorry, I was muted. I suggest that we go through the exercise.
Good.
So we can use to find out programs that are related to chemistry. We can use module keyword chemistry.
Yep.
And then we get a list.
There it is. Yes. So ADF, NWChem, and so on. A couple of softwares.
Mm.
Then we wanted to find an R module, and that we can do with module avail. Module avail
R.
and here, yes, and now we get a lot because we get maybe everything that even contains the character R, maybe. So a better way in this case might be to search for R/ or R/4. So then we get less output. Module avail R/4, and we get, there are three R versions. One is 4.1.2, 4.2.1, 4.2.2. And then our goal was we wanted to load the 4.1.2. That one. Good. And it's loaded almost. Now it's loaded. Now we want to verify. So we can verify with module list. So there it is. We got actually 88 modules, lots, because R depends on many things that depend on many things. We can now do which R, or we can do R -- version to find out, to really verify that we got the version that we wanted. There is a bit of output, but on top of it is 4.1.2. That was pretty good. And how many modules were loaded? I think it was 88. Many.
88 modules.
And now, if we have time, yes, we have time. Let's look at this compatibility. So we want to now load a second module. So for some reason, we want to load the module Ruby, but we want to load a compatible one. And how do you look at this? how do you make sure that it is compatible?
So we see that R is built with GCC Core 11.2.
So 11.2.0, I'm taking a note of that, 11.2.0. And then now we want to try out Ruby, so we do module avail Ruby. And here we see 3 versions, but the one that is interesting to us is the one that is built with 11.2.0.
Yes.
So that's a compatible one. If we load that one, it will be all fine. And we can also, just for fun, then try to load the one that is not compatible and to see how.
Oh, that start
what
with
does
that
the module,
one.
yeah. What does the module system tell us? And we wanted you to know to recognize this and to know what this means. And I think
So we see
if you show a little bit more there, yeah.
the site prevents the automatic swapping of modules with the same name. So we must unload the version GCC Core.
Yeah.
/11.
So what this means is that they were not compatible.
No.
And I think we are out of time.
So a successful module load will give no error message. Like this.
Yeah, we have break time now. Huh?
Yes, we have a break time. Do you want to add something else, Björn and Radovan? We can have 1 more minute if there is something you wish to add on.
So not for me, but we will be watching the document. So questions are still welcome also during break, after the break. But yeah, thanks for the session. Thanks to Björn.
Thanks, Radovan.
Good. See you after the break.
Yes, we will have a 15 minutes break.